A router is also a big computer. Okay, routers are computers. The feature may vary. The job done is different, but even a calculator is a computer. Your cell phone is a computer. Anything that can compute, anything that can communicate, they're all computers. Router is also a computer. In what sense? It's also got CPU to compute the shortest path or the best path to provide some quality of service. And there is need for computing there. CPU is needed. There is an operating system that drives this computing unit, and there are different type of memory to do various functions like storing the chipset programs. We have read-only memory. We have a temporary memory, which is also called as volatile memory, RAM, random access memory. And along with that, we also have a special type of RAM called non-volatile RAM. RAM is a volatile one, but this is a RAM which is acting like ROM, but acting like ROM means what? Acting like a volatile one, sorry, non-volatile one. But if you force it, it will erase. It will change to volatile, meaning a RAM that can save configuration like ROM. In normal RAM, when the power goes off, everything gets vanished, disappeared. But NVRAM, even when the power goes down, the data that you store, the configuration that you store remains there. How long? Until you force it and delete it. So all our configurations that you make on the router get stored in this place called NVRAM. So that when you turn the routers on the next day, you will see all those configurations. You need not to do every day repeatedly the same configuration. Once you do, save it to NVRAM. So that configuration that is stored in NVRAM has got a special name called startup config. So these configurations are stored in NVRAM. So your yesterday's configuration, a week before configuration, month before configuration, all are stored, and you can retrieve those things. You can see those things today. It is all because of NVRAM. Those configurations that are stored and retrieved from NVRAM are called as startup config. But the config that is stored temporarily, which gets erased when the power goes off in this location called RAM, is called as running config. Running config. So we got startup config, we got running config. Startup config is the configuration that can be retrieved, that can also be deleted by us. We can force it and delete it. Whereas this running configuration remains available as long as the power is there on the router. When the power goes off, all the running configuration gets erased. If you want that running configuration, then you have to push it to NVRAM for future retrieval. So we can move the running configuration to NVRAM and make it as a startup config, so that tomorrow when you start up the router, all those configurations get loaded. So these are the types of memories. Okay, we also have flash memory. I was telling you the other day, flash memories are thin plastic silicon chip which can store data like you used to store in the hard disk. But the hard disks are not reliable. It's unreliable. Hard disks are unreliable. When you shake the hard disk, cannot read proper because the hard disk has got disk. I don't know whether it happens in your vehicle. In my Jeep, when I play a CD, that always, stops running if the Jeep jumps. If the road is having a lot of pothole, wherever there is a jerk, wherever there is a jump, this CD player cannot spin because there's a motor in it. As a result, the song that I'm playing in my Jeep will get stuck for a while. See, for CD player, if it happens, it will even happen for the hard disk. Because hard disk also inside they have got a lot of disks like CD, and there is a motor. There is a belt that drives the disks inside. So Cisco, right from the beginning days, they started using flash card. Two advantage. One, very lightweight, thin. You might have seen, laptops, very lightweight laptops, very thin. How is that possible? So thin. It is because of the technology, SDD, storage disk drive, very thin chipset. So this thin laptop, like you might have seen, like Mac Pro, something like that, they are very thin. I don't know how many Mac people there, but I've seen in a lot of MacBook, not my MacBook Pro. MacBook Pro has got hard disk in it. MacBook has got a very thin blade size laptop, blade thin laptop. It's because of that flash card. All the operating system is stored in flash card. Even right in my laptop, I have both. I have one flash card and one hard disk. Flash card, I have kept it for the C drive where the operating system is. Why? Operating system runs all the time. So I do not want to keep it in a hard disk which has got motor and disk. That's not a reliable storage, so I don't keep it there. I have put the operating system and frequently used programs all in flash card. And the other things like the videos of our class, all the stuff I have put in a hard drive. I have both in my laptop. So in short, what I want to say is Cisco, for reliability, they avoid hard drives, they use flash card. That's about the memory. And also we have on the router some ports of different speed. When I say port, I'm not talking about the transport layer port numbers. No, no, no. I'm talking about the physical port that you plug in the wire, the Ethernet cable or the serial cable. Ports. So routers have got ports. It has got network interface card, NIC card. In your laptop, I don't know whether you have NIC card, but in my laptop, I have NIC card. In modern days, laptops don't have NIC card because mostly we connect through Wi-Fi, but some laptops don't have. But most of the laptop will have a NIC card where you connect the physical cable, the Ethernet wire. So routers are having many NIC cards, which are also called as ports. And some ports are very specific for some job, like in order to configure a router, you have a special specified port called console port. You can see in this picture here. This one is written here console. And the olden days, we used to use this auxiliary port, export, for what? To configure this box. Today we use console ports. Auxiliary port is an old technology where we used to have a dialer, like telephone dial. We dial through software to log into this. But nowadays, I have not seen anyone using this for last 12 years. I've never seen this auxiliary port. In the olden days, we used to have, and we also have the other ports. You see the LAN interface ports where we connect the end computers or switches to this, and you also have a USB port. Not on all router you will see USB port. Some will not have. Why you need a USB port? Why do we need a USB port? See, in a computer, why do we use USB port? In a computer, why do we use USB port? If I want to copy something from one computer to another computer, one best option is you copy through network. But what if there is no network connection between these two computers? Then I use the thumb drive, the pen drive, the flash drive, copy it from that computer and bring it and put it in my laptop's USB port and I paste it. Same way. Same way. If you wish to copy an operating system for the router so that you can upgrade to the newer version, you can use this. If your router is running older version and if you find there is a newer version available in cisco.com for the Cisco router that you have, see, Cisco frequently upgrades. If you buy a router, it comes with an operating system, but as soon as it comes to you, they will recommend you to go to the Cisco's website and download the latest version and upgrade it before you use it. Because the one which is shipped to you, installed long back. It was with sales department for a long time and you bought it now. By this time, a lot of versions have changed, newer features been added. So you can use this USB port, download the newer version and install it. For that, you need a USB port. You also have a, a B-type USB, which can be used as a console port. And we also have some special ports like EHWIC, WIC card, wireless interface card, and so on. These things are, okay, you see, there is a flash card, 4 GB flash cards. This is just a slot. This is empty slot. It's covered using some metal lid. You unscrew this here, and then you can take the lid off, and you can insert some additional ports if needed. Because as of now, you got only 2 ports, one here and one here, 2 LAN interface ports. You want more, then you can put it here. More ports. You can add it here. More ports. All right. Now, what do we store in the flash card? We saw in this picture here, this page here, all our configurations are temporarily maintained in RAM, and when you store it, it goes to the NVRAM. In the ROM, only the programs that are needed to run the motherboard is in ROM. We don't have anything to do with that. Now, what is there in the flash drive? If all our configurations are stored here, and if all our configurations are maintained here, what is the purpose of flash drive? The operating systems are kept in the flash drive. You see, in our laptop, we have C drive. I'm using that only for operating systems and programs. I don't keep my documents or videos there. I keep it in hard drive. Likewise, Cisco also keeps their operating system in flash. Only operating system. Your configurations will not sit in the flash drive. Your configuration gets stored to NVRAM only. So your operating system will always remain fresh. When you do some changes to the operating system, actually the changes will not be impacting the original copy of the operating system. Only the configuration will be there in the NVRAM, and flash will be there in, sorry, operating system will be there in flash, always fresh. You see, Windows operating system, if you take in your laptop, when you change the desktop picture, the Windows operating system gets changed. When you create some document, when you go and change some power supply settings or brightness settings, all these changes that you make on the laptop impacts the operating system of the laptop. Whereas in Cisco, see, they're very clever, without disturbing the original operating system. All the changes are made, and the changes go separately to NVRAM and saved there. How is that possible? You see, this flash, which has got Internet operating system. When you on the laptop, when you on the router, from the flash card, the operating system gets loaded. That's not the way I should say. The copy of the operating system gets loaded from the flash. It's not the operating system itself loaded. The copy of the operating system gets loaded. You will see like dot, it will load. First time when you on the router, you will see dots, which means it's loading the operating system. Once the operating system is extracted to the RAM, the control goes to NVRAM. On the way, it will go to NVRAM and copy all the configurations that you made yesterday or before, append to the operating system, means attach all those configurations to the operating system, and it will appear on RAM for you. You see, the operating system copy gets your previous day configurations and got loaded to NVRAM. So the original operating system is still there. A copy, an instant of operating system is what loaded. So whatever the change that you make, you are making to that instant. Using that same instant, you also push all the yesterday's configuration to NVRAM, and the configuration is stored there. And tomorrow when you on the router again a copy is made from the operating system. Again, this NVRAM gets loaded to the operating system, and RAM will show you all the configurations that you made along with the operating system. So clever, no? The original operating system never gets corrupted by our any wrong configuration. It remains always fresh. Right? Okay. I was telling you the configurations that are stored in the RAM is called as running configuration. The one which is stored in the NVRAM is called as startup configuration. This ROM is not for us, it's only for the motherboard to function. Yeah. All right. What is the function of a router? To connect between different networks. You see, you can see here a multi-layer switch, which can do both layer 2 as well as layer 3. All the end devices are connected to layer 2 device. Those layer 2 devices are connected to multi-layer switch, which can be both router and a switch. At last, they are connected to the edge router. Edge router is connected to the internet cloud. So this is one office, central office. We call this as access layer. Access layer. Access layer is not capable of routing. Access layer is not capable of routing. The next layer where you see the multi-layer switch, we call this as distribution layer. Distribution layer, why it is called as distribution layer? It is capable of distributing the route from one network to another network, one VLAN to another VLAN. That's what we did, no? Intra-VLAN routing. Distribution layer. And then this one we call it as core layer of our network. Core. And this is also edge, core edge. So this core edge is connecting to the internet. Likewise, there's another home office. You see, home office meaning what? It's not a big enterprises. In our home, we will have just one router. And that router is Wi-Fi capable. From that Wi-Fi capable router, we connect to laptops, more than one. We connect to the mobile phones, more than one. We connect to the printer at home. You can print from your mobile phone. You can print documents from your laptop to the printer because the printer is in the network, Wi-Fi coverage area. And branch office. If you see branch office, you don't have the distribution layer. This is a small branch office. It has got some IP phones with the computer. It has got some authentication server, laptop. It has got printers, some servers, and they're all connected to a layer 2 device. At last, they are connected to a router, which is interconnecting networks. It connects this portion of the network to the internet, which is a very big network. And using internet, branch office now can communicate to central office. So without router, connecting between networks, it's not possible. So now how this router works, it's a very interesting one. Listen, whenever this PC, whenever this PC tries to communicate to another network, for example, if a computer in 192.168.1 wants to talk to 192.168.2, see, they are in two different networks. They are in two different networks. This is a mistake, okay? There's a mistake in this picture. There's supposed to be 3. It's not 2. This is 2. Okay, so if someone from this network, meaning what? This is a network, meaning what? These all are in same network, so it is on LAN, on local area network. This is another LAN because this is all in 192.168.3 network, that is one network. In between, to connect these two router, you have two network. Now the routing logic is this. If someone from left side, let me call it as A, if A wants to talk to this computer here, B, if A wants to talk to B, the traffic will be sent, it cannot fly and go. It will only send to its own gateway. This computer cannot go straight away to this one. So whenever this computer wants to go to different network, it will deliver the packet to the gateway. Whoa, what is the gateway? Who is the gateway? Router is the gateway. The packet will go to the router. And the router will route the packet to the next router. And the next router, if it finds another router, it will go to another router. If it finds the destination directly connected, it will deliver. So what I am trying to say is, traffic will jump hop by hop. What is hop? One router to another router. So if you see here, this router is connected to dot 2 and dot 1 network. So you can see here directly connected on F00. This is F00. One network, isn't it? One. And directly connected on serial 000. If you see someone drawing like this wire, it means serial. Serial 0/0/0. It is two network. So 1 and 2 are directly connected. C means what? Connected. This is the output of a routing table, show IP route. When you type show IP route, you will see this type of output. C means connected. You see here, C, C. What is S? S means statically returned route. Where is the S? Here, static. In order to go to 3, I told you this is not 2, this is 3. Router 1 do not know 3 because router 1 is not connected directly to 192.168.3. It is not connected directly to 3. So the administrator writes a static route. Administrator tells the router, if you receive any packet for this network, you just send it to this address. This is the address of router 2. Just send it to this router. And once this router receives the packet, it finds that 192.168.3 is in this direction. It will deliver the packet in that direction. It will forward the packet in that direction. So that is how the packets are moved from one hop to the other. All right. So a packet is coming, you see, the packet is coming on the ingress interface. What is ingress interface? The interface on which the packets are received. Packets are received on one port, and then it goes through the control plane. What is control plane? Control plane is the routing table. Control plane is the one which says on which exit interface it needs to be sent, on what egress interface it needs to be sent. So what happens is the very first packet comes here, goes to the control plane and learns the exit interface. Second packet onwards, this data plane itself will know the exit interface, so it need not to go every time up. It need not to go every time up. First time you do not know. So you go up and then learn it and then you forward it. Second time, you will not go up. You will straight away go to the exit interface because you already learned the exit interface for the destination. The router, when I say you, it's not you, the router. The router knows the exit interface. First packet comes, don't know. Who do not know? The forwarding class cache. The cache memory don't know on which interface to send. The data plane don't know on which port the data need to be sent. So it goes to the control plane and asks, hey, this destination, how can I send? The control plane checks the routing table and say, oh, 192.168.3.0. Oh, no problem. You just send it to this interface where you have 2.2. 2.2 is on serial interface, so it pushes via this interface. Who gives that info? Control plane. This is the control plane of a router, routing table. So second time when the packet comes, it need not to go to the routing table and check. It will directly forward it because the memory, the cache memory is having the info. It is having the info. All right. So this is what called as fast switching. This process is called as fast switching. Older days, every packet needs to go to the control plane. Then it is called as process switching. But this one, only the first packet goes, second packet onwards, it is just going through the data plane, fast switching. All right. So fast switching is less CPU intense, it's faster. Cisco came up with a new idea. We don't want fast switching. We don't want fast switching. We don't want process switching. Let us go with Cisco Express Forwarding. What it is actually, before the packet comes, all those routing table information in the control plane is downloaded to the layer 2 memory, the data plane itself. It is downloaded to layer 2 level. This control plane is the routing table, layer 3. All the layer 3 informations are downloaded to the layer 2 table. So when a packet comes, this guy itself knows the exit interface. It need not to go here and find it. Before the packet arrives, all those routing informations, control plane informations are placed inside the data plane itself so that just by going through the data plane, you can exit. So you have avoided going through the routing engine because it takes time. This is more faster. Which one? Ceph. Ceph, Cisco Express Forwarding. So what is Ceph? Ceph is memory in layer 2 in data plane. where all the forwarding informations that is there in the routing table in the control plane downloaded to this data plane, so that when a packet arrives, it need not to go through the control plane all the time, which is time consuming. So this one, which we earlier called as fast forwarding cache, now you don't call it as fast forwarding cache, you call it as forwarding information base, because you have the information to forward. You don't need to go to a control plane to ask how to forward. So Cisco routers are faster because they maintain the control plane information right in the data plane itself, so that you can avoid looking into the control plane every time. So this is more faster, right? All right, about a protocol called CDP, Cisco Discovery Protocol. We learned CDP and we will do the discovery of network in our next lab section. I'm not going to do these things now. Not so important thing. These are all simple general knowledge stuff. Okay, this is an important page, but I wish to continue